Our next example is a factored form trig function. So when you have it in factored form, really what you need to do is just take each part and use the zero product property and set them equal to 0 and solve each one individually. So I have the first one and then I have the second one. So when I solve this one, get the trig function by itself. So I have 2 cosine of x equals square root of 2, and then divide both sides by 2. So I'd have cosine of x equals square root of 2 all over 2. Now in order to solve this, I'm going to use my calculator. So I'm going to go cosine inverse. So second cosine inverse of square root of 2 over 2. Those should be your favorite ones. Those are your 45-degree angles. But I'm going to type it in, square root of 2 divided by 2. Oh, I mistyped it. Square root of 2. Got to get out from underneath that radical. There we go. Divide by 2. So we get 45 degrees. So my first answer is 45 degrees. And we know cosine is our x value. So I have a 45-degree angle here. That's my first one. And then where else are my x's positive? It's going to be straight down here. So this is another distance of 45 degrees. So I just need to find both of those. So one answer, like I said, is x equals 45 degrees. Then the other one, we would go, this is 360 minus the 45 degrees. That's the negative direction. 360 minus 45 degrees. So x would equal 315 degrees. So these are my two answers in degrees. And then from here, I will go ahead and convert them into radians. Okay, so I would take 45 times pi over 180. And on my calculator, I would do 45 divided by 180 math frac, which reduces to pi over 4. So that's my first radian. And then my other answer would do the same thing, times pi over 180. And if I do that, I should get 7 pi over 4. Okay, so that's my answer for the first part. Okay, and those are both in between 0 and 2 pi, so that works out. The next one is tangent. So I'm going to do tangent, and I get tangent all by itself, and I get the answer of 1. You could think about this in terms of sine and cosine, but the easier route is probably just to do tangent inverse on your calculator of 1. So I would do second tangent inverse 1, and it tells me 45 degrees. Why does this make sense? Ooh, why is this going like that? Well, if I'm going to have, remember, tangent is equal to sine over cosine. And so the only way to get an answer of 1 is to have the number sine divided by cosine to be the same thing. And the only place that happens on my unit circle, which I have right here, is at 45 degrees. Square root of 2 over 2 over square root of 2 over 2. That gives us an answer of 1. So one answer is x equals 45 degrees. And I always have to think, where else is tangent positive? So we for sure are in quadrant 1, it's positive. And remember, tangent sine over cosine. So if I just think about my ordered pairs, in quadrant 1, we got positive, positive. And then in this quadrant, it's negative, positive. So if I did sine over cosine, it'd be positive over negative, so it'd be a negative answer. So it is not a positive answer here. Down here, I got ordered pairs that are negative, negative. So negative divided by negative is a positive. So actually, my other answer would be down here in quadrant 3. And this is a distance of 45 degrees again. And so my other answer is this is 180 degrees plus 45 degrees. So then we're at 225 degrees. So x equals 225. And then in this quadrant, we got positive, negative, which would give us a negative tangent. And we're only looking for positive answers because it says 1. So my other answer, we got 45, we already converted, was pi over 4. And then 225, if you take it times pi over 180, pi over 180. So you would take 225 divided by 180, math frac, and you get 5 pi over 4. So for this problem, we really got pi over 4 for an answer twice, but when you're listing your final answer, you only have to write it once. So we'd have pi over 4, I'm going to go in order, then we got 5 pi over 4, and lastly 7 pi over 4. Those would be all of my solutions for this example.